In this example, I'd like to show you another use for option D. Option D is usually used for calculating the wire size required for a 25, 100, or 70 volt speaker line. But suppose you had a situation like this with an audio source and 15,000 feet of wiring into a 1200 ohm input impedance. And you want to know, for this circuit with a single 1200 ohm input impedance, 1200 ohm load, how much audio loss would occur in the 15,000 feet of wiring for 26, 24, and 22 gauge wire. Well, going into option D, I'll just press enter to go through these first few screens of text. Now I need to choose an amplifier size. Well, what you'll find is the audio loss is independent of the starting voltage or the source voltage. So what I'll do is I'm going to pick 25.5 volts simply because it gives me a greater range of wire sizes to evaluate. Press A. For our purposes, I don't care about the acceptable percent power loss. I'm going to look at all the wire sizes and the losses that occur. So I'll just press enter to accept the 5%. I do need to determine a wattage. That we have a 1200 ohm load. I need to know what wattage that would be with the 25.5 volt amplifier. And I can determine that by using option J, Ohm's law. I'll press J, and I'll put in 1200 ohms and 25.5 volts. And the program calculates that that would be a 0.541875 watt load. So I'll simply enter that right here. I said it was going to be 0.541875, and my wire length was 15,000 feet, if you'll recall. Now from this point I'm just going to press enter, enter, and I'm going to press 2 to list all the wire sizes and the power losses. And I can see that 26 gauge wire would result in 6 dB of loss, the 24 gauge wire would be 4.3 dB of loss, and 22 gauge wire would be 2.94 dB of loss. So along the 15,000 feet of wire into a single 1200 ohm load, 26 gauge wire would result in 6 dB of loss, which means that whatever audio level you had here at the source, the audio level would be diminished by 6.108 dB at the load. 24 gauge wire would result in 4.306 dB of loss, and 22 gauge wire would result in 2.944 dB of loss. It makes sense if you think about it, because the smaller gauge sizes result in bigger wire, more copper, less resistance, so you lose less signal. That's the end of this example.